Modern periodic law. Modern periodic table depends upon modern periodic law. Modern periodic table depends upon modern periodic law. Modern periodic law. What is the modern periodic law? It is based on atomic number. We have already seen atomic number, and it is denoted by Z. Atomic number and denoted by Z, represented by Z or Z. Okay, right. So definition: modern periodic table, modern periodic law. Definition: physical, physical and chemical properties, physical and chemical properties of an element, physical and chemical properties of an element are the periodic functions, are the periodic function of its atomic number. Okay, what does it mean? That means the physical and chemical properties of an element in a periodic function is dependent on its atomic number. So with the help of atomic number, we can able to understand the physical and chemical properties in a when arranged in a periodic function. That is what it is saying. Okay, right. So now as we go for proceed further, we can understand. Okay, you can understand what actually it is happening. So in our case, we need not to learn all the 118. Need not to learn all 118. We are only going to see S and P. S and P blocks only in our syllabus at our level. Okay, right. The periodic table in generally it is dependent. It is divided into four blocks. Divided into four blocks. They are S, P, D, and F. See, we'll see what SP and D. SP, D, F. Okay, right. So if you take a periodic table, this is the skeleton of periodic table. Okay, skeleton of periodic table. Right. This is S. This is P. This is D, and this is F. So this is the skeleton of periodic table. Right. It is divided into four blocks. Four blocks: S, P, D, and F. So we'll mostly in our syllabus we are going to discuss about S and P. Right, S and P block. This block and this block. Right. Right. Before going to discuss detailed about the four blocks and the periodic table, we need to know some certain basics. We'll discuss the basics and we'll go into the major subject. Okay, right. In any particular atom, in any particular atom, any element, we have shells. We can divide it into shells. For example, if this is the nucleus of an atom. Okay, so there will be shells. Shell number 1, shell number 2, shell number 3, and shell number 4. So this is denoted by K. First shell K, second shell L, M, and N. So these are the shells. If in any atom which has nucleus, there will be this kind of shells. Okay, right. So these shells K, L, M, N, these are the shells. Okay, within these shells we have subshells also. Subshells. Okay, before going into subshells, we'll see how many K has a capacity. K, L, M, and N shells have a particular capacity, accommodation capacity. Accommodation capacity. That means what? How much it can take. Okay, how much it can take, how much it can accommodate. Okay, right? So the accommodation capacity of K is 2, first shell. Okay, second shell is S. Okay, L, 8. Okay, in M it is 18, in N it is 32. So these many it can accommodate. K can accommodate 2, L can accommodate 8, M can accommodate 18, N can accommodate 32. Okay, so it is governed by 2n square formula. Okay, right? So within these shells also there are some subshells. We denote the subshells as subshells. Subshells within K, L, M shells we have subshells. Those are denoted by S, P, D, and F. Okay, right? So these SPDF will lie in, there are subcell, no, where will be there, where they can be accommodated, they will be inside here. Yes, subcell. K is a cell, within that subcell. Yes, L is a cell, here we'll have S and P. Okay, here what we'll have, S, P, and D subshells. Here what we'll have, S, P, D, and F subshells. So for each and every shell, we'll be having some subshells. They are denoted by SPDF. So here, if any electron, if any element having the same shell number, subshell number, they are grouped as the, in periodic table, they are in the S block. So in a valency shell, if it has P, it is ending with P subshell, they are subgrouped into the P subshell. If the electrons are in this D group, so they grouped it into the D. In the likewise in F. So in that manner, they have grouped everything in S, P, D, F format. Understood? Understood? Yeah, we can identify them with the help of number of, yeah, two valency cell. If you have two number, if it is having 6 in the valency cell, if it is having 10 in D, if it is having 14 here, then we can easily identify. So as we go further, you will understand it. Okay, right? So take it down. Take it down. We'll go into we'll go further. Okay, right? Done. Okay, okay, right. Done. This is also done. Yeah, yeah, yeah.